Hi, Dylan. So I've just started a little bit of a head start here in terms of writing out the solution, so the video will be a bit shorter for you. So for any Pythagorean triangle, we can start with the a squared plus b squared equals c squared idea. So I've used x squared plus y squared equals z squared just to represent the x and y here. So the length of the ladder can't change. It's got to be constant at 10, and so its derivative will be 0. When I take the derivative, I'm using implicit differentiation again, that idea, because I'm trying to find how fast things are changing with respect to time, right? Because they're talking about rates. So for the x squared, I would do the power rule first of all for the x squared and get 2x, but I need to multiply that by the dx dt, sorry. And then the same thing for the y variable. I would have 2y times dy dt. But the 10 squared, or 100 if you prefer, has a derivative of 0, and so that's why I have it equal to 0. So if I start by filling everything in this line here that I know, then x is 3 and dx dt is 2 meters per second, so I can put that in. That's how fast x is changing, and that's increasing, so it's positive. Then I have 2y times dy dt. So I must be able to fill one of those two variables in, one of these two guys, or else I can't solve this equation. And that leads me over here. In the little box here, I've used Pythagorean theorem to solve for side y in the right angle triangle when x is 3 and the hypotenuse is 10, because that's the instantaneous values that they give us. That's the instant that we're looking to solve this triangle. And so solving for y there gives me the square root of 91. I don't have a calculator in front of me, but I'm guessing that that's going to be 8.5 or somewhere in that range. And so that allows me to fill in the instantaneous value of y back in my equation. So I have 2 times 3 times 2. I might as well multiply that out and get 12. And then I said that y is probably about 8.5. I might be off by a decimal place there. And then I've got dy dt equal to 0. So all you need to do now is solve for dy dt, take the 12 over to the other side, and you can see that it's going to come out as a negative because we have the ladder falling down the y side of the triangle, and so that distance is decreasing over time. And so if we continue to solve this, we would have 17 dy dx, or dy dt, sorry, equal to negative 12, and dy dt equal to negative 12 over 17. And that's going to be in meters per second. Sorry for the messiness. I don't have a stylus. I'm writing with my finger. So that's how I would handle a question like that. Anything that's Pythagorean gets set up in the a squared plus b squared equals c squared formula. And you work it down until you have only one unknown.